surprising they won't agree on velocity measurements, since that's what we make a velocity measurement using our distance and time measurements. So if we go back to the idea of throwing a baseball on a train, we can say the velocity of the train relative to the ground is VAB, and the velocity of the baseball relative to the train is VBC. Newton would say velocity of the ball relative to the ground is just the sum of the two, VAB plus VBC. Einstein says it's VAB plus VBC, but then we have to divide by 1 plus the product of those velocities over c squared. So let's see what we actually get. We would get 35 meters per second, first semester physics. Now we do this calculation that Einstein tells us to do, and we say 35 minus that, we get 10 to the negative 13 meters per second difference. So that's about 1 part in 10 trillion. That difference is completely meaningless. There's no way we would know the velocity of the train or the baseball at anything like enough accuracy to justify including this tiny correction. This is the same reason we don't have to calculate a gamma factor to see how much slower even an astronaut on the space station ages than we do. We can calculate that if we want to and see that if we put in 7,500 meters per second, which is how fast they're orbiting relative to us, and subtract it from 1, we get about 3 parts in 10 billion. So that means someone traveling at that speed for 32 years would age a tenth of a second less than you did. There's no way that's going to be significant. At faster speeds, though, it starts to matter. What if our train is moving at 0.8 c and we fire a bullet towards the front of the train moving at 0.5 c? Again, Newton would predict 1.3 c, since we would just add them together. Don't ever do this on a test. Don't fall for it. I might very well ask you something like this and try and trick you, but you should never measure a speed greater than c for any moving object, and you won't even measure a speed equal to c if the object has mass. So Einstein's prediction is this 1.3 c, but we divide it by 1 plus the product of these things. So 1.3 c divided by 1.4 is about 0.929 c. It's still less than c, which better be the case because it's something with mass, but we know it's larger than either of the ones that went into it. It's moving faster than the train still, certainly. What about instead of a gun if you used a flashlight? So now what speed would people on the ground measure for the light? Newton would say 0.8 c plus c. Then Einstein would say, no, you have to divide that by this term on the bottom. 1.8 c, the term on the bottom is 1.8, so we get c. Not surprisingly, people on the ground measure speed of light just like you do for that flashlight. On the other hand, what if you fire the flashlight towards the rear of the train? We still have the same value for the train speed. Now I put in negative c for the flashlight, the light coming out of the flashlight. Newton would say negative 0.2 c, but Einstein would then divide by 1 plus the product of these speeds. Einstein would get negative c. Again, it's moving at the speed of light, just backwards.